Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will learn how to create an EKS cluster along with the VPC configuration using Terraform. Also, the EKS cluster that we are going to create in today's video will have the worker nodes set up using auto scaling. We'll also create security groups to secure the VPC along with the AKS cluster. So it's going to be a very interesting video. Please try to watch it till the end. All the Terraform files that I will be using in today's video are already uploaded to this GitHub repository. I've also created a README file that helps you install the required packages and execute the Terraform files after watching this video. So you can simply start this repository, fork it, or clone it to implement the project after watching this video. So let's get started. Firstly, let's try to understand through a diagram what exactly are we going to do. So we will have a local machine or any kind of virtual machine, and within the virtual machine, we will have Terraform installed. So let's say this is my laptop, or for some reason, if you don't want to use your laptop, this can also be your virtual machine. Within this virtual machine, first thing we will do is we will install Terraform. Once Terraform is installed, we will connect Terraform, or we will configure Terraform to connect to your AWS account. And when someone executes, it can be you or it can be anyone else, when they execute the Terraform project, which is connected to the AWS account, it will create a VPC, right? So it will create a virtual private cloud. And within the virtual private cloud, it will create a EKS cluster. This is very similar to how people do it in organizations. So we are trying to implement real-time scenario. And additionally, like if you want to understand this in detail, so the EKS cluster will have auto scaling, which creates virtual machines or EC2 instances. Minimum or desired state is 2, and maximum of the auto scaling group, the maximum number of nodes, when there is more traffic, the EC2 instances will scale up to 6. But the desired state will be 2. That means by default, the EC2 instances or the worker nodes for the EKS cluster will be 2. When more number of people, if more number of people try to access the resources within the EKS cluster, the nodes can automatically scale up to 6 as well. And we will also create some security groups and assign them just to secure, or just to give you a feel of how does a real EKS cluster within the VPC look like. So this is the entire project that we are going to implement. And again, these steps are also available in the README file. So if you go to the README file, first thing is we will install AWS CLI. Then we will install Terraform. Then we will connect Terraform with AWS. We will initialize Terraform, run the Terraform plan, and run the Terraform apply. Of course, I will explain you how to write these Terraform files, what should be your approach. All these things we are going to discuss, right? So let's try to write down the steps one more time, just that we are all clear before we start with execution of the project. And most importantly, this is the critical part, right? Writing the Terraform files, you can refer to the documentation, but all that you need to understand is how to even write those files. So step 1 is going to be, we will install AWS CLI. So why we need AWS CLI? I'm going to explain. Step 2 is we will install Terraform on our local machine. Now, assume this is your Terraform and this is your AWS account. Now, for Terraform to talk to AWS, you need AWS credentials, right? Right. So Terraform should have the AWS credentials to talk to AWS and to configure this for Terraform to access the AWS credentials, to access the AWS account. We will be using the AWS CLI. Step 3 is the same thing. Connect Terraform once you install. And step 4 is to execute the Terraform to create the resources. So let's get started. And firstly, we will install the AWS CLI. Some people might already have the AWS CLI and Terraform, all the required things. So you can skip that part and directly move to the part where I explain the Terraform files. But I just want to make sure everybody is on the same page. So to install AWS CLI, just search for install AWS CLI on your browser. Click on the first link that you get. Getting started, to the left side, you have install update. Depending upon your operating system, if you're on Windows or if you're on an EC2 instance, which is a Linux distribution, let's say of type, it can be of any distribution, right? So you have the shell script command that are available here. So you can simply copy this and execute these commands towards the end. Like, you can just follow the same steps that are provided here. If you're using Linux distribution, and just copy the commands here. The first one will download the AWS CLI zip, and then you are just granting the permissions. Finally, you will execute it by unzipping the zip file and run this AWS install command. If you're on Windows, let's say, so let me scroll up. So if you're on Windows, again, you have the commands. So you just have to copy this MSI, directly download it, or once you download it, click on the next button, or you can also execute the MSI from your command prompt using these commands. End of the day, the verification is very straightforward. Just run AWS ---- version, and you should see this output. When you see this, that means the AWS CLI is installed and configured properly. Once this is done, next step, if we go back to our eraser board, so this is a new whiteboard that I'm using. This is called eraser.io. Previously, I was using the tutorials .1, right? I found this interesting, so I just picked this up. Anyways, so the next step is Terraform. So I will install Terraform now. For that, again, just search for install Terraform. Go to the HashiCorp developer. To your left side, you have the install page. Just pick the operating system. Similarly, if you're on Linux, you have set of commands to run. If you're on Windows, you can use Chocolatey, or you can also use the manual installation, whatever you feel is good. If you're on Mac, you have the brew commands, using which you can use the Terraform. So these documents are self-explanatory. You can just follow them. Finally, once you install, just run Terraform version. And if you see the output like this, that means your Terraform is installed and configured properly. What is step 3? We have AWS CLI, we have Terraform installed. Step 3 is to connect. Now to connect, all that you need to do is just run this command called AWS configure, right? So if you simply run the AWS configure command, Terraform will be able to connect to your AWS account using the security credentials. So if I run AWS configure, it will ask me for access key ID. But Abhishek, where can I get this access key ID from? Right? This is a very genuine question. For that, just go back to your AWS account. I believe you have an AWS account. Without that, you cannot do this. So I'm using a free trial AWS account and I'm using the root user. Either you can use the root user or you can use any IAM user. It's up to you. But if you're using it on your production or in your office, in your official account, then please make sure you use the IAM user only with the valid permissions. So click on the arrow here, click on the security credentials. If you scroll down, you have this section called access keys. So within this section, click on the create access key. Because I'm using the root user, it is warning me that using the root user is not a best practice. But I'm doing it on a demo environment where I will just delete the entire infrastructure. Probably I might also delete the AWS account in a few days. So this is fine. Just copy this access key, paste it here. Next, it is asking me for secret access key. Again, the same thing, just copy it and paste it here. Default region, you can keep it anything. If the default region is US East 1, that doesn't mean you will be using AWS CLI only in the US East 1 region. By default, it will create in East 1, but you can use East 2, West, South, anything. Finally, the default output format, keep it as JSON, there is no problem. And click on the enter. I terminated it because I already have AWS configured. So with this, you will have the AWS CLI also configured. But your question can be, Abhishek, I have configured AWS CLI, but how is that the AWS CLI that I have configured will help Terraform to connect to AWS? Because our end goal is to connect Terraform with AWS, but not AWS CLI with AWS. So the point here is Terraform, which is installed on your machine, will use the security credentials that are configured by the AWS configure command. So when you run AWS configure, the security credentials are stored on your machine within the configure file. So Terraform will use the they are secured in the credentials file. So Terraform will use those credentials to connect to the AWS, right? So the connect part is also done. Now we are just left with the execute. Of course, execution is very simple, but we need to understand how to write the files here. Now that we have the files, we can simply run Terraform apply and all the files will get executed and you will see the infrastructure getting created on AWS. But that is not important, right? What is more important is to learn how to write these files. So here you have 1, 2, 3, 4, 5, 6 Terraform files that I have written. Why did I write these many Terraform files? And what is each Terraform file doing? For that, again, let's go to the whiteboard. And if you understand the requirement, right? So we are, if this is the AWS account, so within the AWS account, we are creating VPC. And within VPC, I have created EKS and some other configuration like security group, right? So the important thing with Terraform is always try to write down what you want to create using Terraform and try to break into number of Terraform files. Of course, I can simply write this in one Terraform file called as main.tf, right? I can just create a Terraform file called main.tf. And within this main.tf, I can write the entire Terraform code. So all the resources that I want to create, I can just put it inside one file. But it is not a best practice. Now, one is it makes the readability difficult for anyone who wants to read this Terraform files that you have. Let's say tomorrow there is some issue with the security groups. If they have to just go through the main.tf file and find out where the security group related code is and fix that, it becomes little difficult. Instead, if you observe carefully, for security group, I have a different Terraform file. For VPC, I have a different Terraform file. For EKS, I have a different Terraform file. So if the issue is with security group, let's say tomorrow they have to modify, someone has to modify a inbound traffic rule. They can simply come to the security groups.tf, look where is the inbound related code is, and here probably add one more CIDR block range, or probably add one more port or anything into this security group. Or if there is any change in the outbound, they can simply come here and update the outbound configuration, right? Or if there is anything that is required to be updated in the VPC configuration. So they can simply go to the VPC configuration thing and update something in the VPC file. So this is how you should be structuring your Terraform. Step number one. Step number two is always try to use modules if possible, right? This is another best practice. And I've explained all of these things in the Terraform Zero to Hero repository, playlist. If you go to my YouTube channel, there is Terraform Zero to Hero playlist where we have learned Terraform right from the scratch. We have everything that is required to start learning Terraform. Of course, you can start with that. So try to use modules as much as possible. What is modules? Modules, anything that is a repeatable code, right? Any piece of code that you are either using or any piece of code that you are writing, contributing, if you put that into a module, later point of time, that can be shared and reusable. Best example is whatever we are using here today, VPC or EKS, all these things that we are using are the most commonly used things, right? So if you write the Terraform code for VPC, this can be used by other people within your organization or other people outside your organization as well, because more or less the VPC code will remain the same. The Terraform code for VPC creation will more or less remain the same. Similarly, EKS also, more or less within your organization or outside your organization, the Terraform code that you write for EKS will remain the same. So what you can do is whatever the resources that you want to create, firstly check if there are inbuilt modules available for them. Both for VPC and EKS, we have the inbuilt modules that is in the Terraform module registry itself, where we can use both the VPC module and EKS module today. You don't have to write everything from the scratch. We will be using these modules, and wherever possible, try to use the modules. Now I'm giving the example of this one. In future, in your organization, you might implement, let's say, S3 buckets, or you might implement a complex infrastructure. Try to see if you have modules within the Terraform. Let's say you don't have an inbuilt module. Next thing that you will try to figure out is the organization that you have joined. Do they have modules for the task that you're going to do? Sometimes within the organization, there is project X and there is project Y. So a DevOps engineer might have written the Terraform files for project X to create S3 bucket plus EC2 instance. I'm just giving an example. Now, after 1 month, when you are working for project Y, you have the same requirement to create an S3 bucket plus EC2 instance. This person has already written the code. Now, if you also write the code, one is it becomes duplicate. Two is in future, if there is any security update or if there is any change to how the EC2 instance is created in AWS, you have to update both this place and this place, right? Instead, if initially one person writes the code, converts this into a module, then future for project X, Y, Z, A, B, C, we can just use this module, call the module, and just pass the variables to the module. In future, if the EC2 instance or S3 bucket creation changes, you can just update in one place, and rest all are anyways just the variables, so that will not be impacted. So for various reasons, using module is a best practice. So we will use the same two things. One is break down the Terraform files, and second is use the modules. That's exactly what I've done. So if you go to the GitHub repository, for VPC creation, what I have done is I have used an module called VPC, which is an inbuilt module. So whenever you write the module, you provide the source, and the source explains from where the module is taken. Here, the source is Terraform AWS modules. That means it is taken from the official Terraform AWS modules. In case it is not available in the Terraform AWS modules, and this is available within your organization, someone else has written, so you can just replace this particular thing with a GitHub repository location or wherever the module is put in your organization. It is also important to provide the version of the module. If you don't provide the version of the module, Terraform will not understand. Let's say initially a version of this module is written. After a year, a new version is rolled out. Then after 6 months, a new version is rolled out. If you don't provide the version, or if you're using an outdated version, both of them can cause an issue. So always try to provide a version. And if you're writing it for the first time, try to use the latest version. So if you search for Terraform VPC AWS, I'm already using the latest version of the module. So this is the Terraform registry. Here you have all the modules. You can search for the modules here. And the latest version is 5.7.0, which I'm using. And if you're using modules, writing it is very, very simple. All that you have to do is just pass the variables that are required to create VPC. I cannot call them literally variables, but just for easy explanation, I'm just calling it that way. So if you go to the module documentation, click on the example. Now you have the complete VPC examples, which provides what are the inputs that are required, right? And what are the outputs that you get. So you need to definitely go through the documentation. Even if I am writing, I will have to go through the documentation. Even if you are writing, you have to go through the documentation. So these are the parameters that are required. One is you have to provide the name of the VPC, CIDR block. If people are familiar with creating VPC through the AWS portal, they will also have this idea. So you need to provide the name, you need to provide the CIDR block, you need to provide the availability zones in which the VPC is available. You have to provide private subnets, public subnet. Do you want to enable the gateway, the NAT gateway, single NAT gateway, enable DNS host names for your VPC, DNS support? So I've taken all the things that I require. Let's say in your project, you don't need these two things. You can simply remove them. There is no problem. Unless and until if something is mandatory, you don't have to use it. For example, if you don't provide the name for the VPC, then that's a problem. You should definitely provide the name. You should provide the CIDR block range. It is good to provide the availability zones, but some things like tags, you don't have to provide. Now you might ask me, but Abhishek, how will I come to know these things? Same thing. One is go through the documentation, or second is with practice, right? As you keep writing the Terraform, as you keep writing, uh, keep creating resources on the AWS portal, you will understand what are the things that are mandatory and what are the things that are not mandatory. So these things comes with practice. Perfect. So within the modules, I've provided the tags. So these are bunch of tags. Even if you don't provide, that is fine. But these are some of the mandatory things that you want to get. And at the beginning of the file, I have also provided the provider as AWS. If you don't know what is provider, so Terraform can connect to multiple things, right? Terraform can talk to AWS, Terraform can talk to Azure, Terraform can talk to GCP. How Terraform comes to know where it has to create the resources that you are writing in this file? You know that VPC is AWS. Probably Terraform does not know. So what you will do is you will define the provider. In this case, provider is AWS, and the region in which Terraform has to create these resources, you should also provide them. Abhishek, what is this var.aws region? I will come there in a second. But for now, just understand that you will provide the provider configuration. And I've also used a random string here. Why I've used a random string? When I create the EKS cluster, I want to make sure that the EKS cluster name is unique every time that I create, instead of just creating the EKS cluster as Abhi EKS cluster. I just want to create that as Abhi EKS followed by 8 number or 8 letter random string. So I will be using this random string, which I will show. So this is about VPC. And then once the VPC is done, second thing is to create EKS cluster. So even for the EKS cluster, I will be using the module called EKS. So I'm using the source module from same thing, Terraform AWS modules itself. So if you just go here and search for Terraform AWS modules, someone might ask me, how do I know what are the different modules that are available? Just go to this thing, Terraform AWS modules, collection of Terraform AWS modules supported by the community. So these modules are not written by your organization, but these modules are supported by the community. Now, if you don't trust these modules, you can also create your own modules within your organization. In the Terraform Zero to Hero playlist, I have explained how to create your own module. So using that way, you can create your own module. Otherwise, if you trust these community modules, you can use it from here. Previously, I used this Terraform AWS VPC module. Now I will just search for EKS. It says Terraform module to create AWS EKS resources. So click on this one, and within this, you can either go for the submodule and look into the documentation, or just go to the examples, click on the examples. So, here you have details like EKS managed node group or Fargate profile, Carpenter, Outposts, self-managed node groups, or user data. I'm going with self-managed node groups where I want to create my managed node groups, right? I will be using a autoscaler using which I will create the EKS cluster, right? So if you go through this documentation, again, you will be able to frame the EKS cluster details that I have framed, where module is EKS, source is the same thing. I've used the latest version. Cluster name, using that random string, I have formed the cluster name and I am using it here. That is why I'm using this local. So local is used to represent if I'm creating the cluster name in a different Terraform file, and now using local, I am referencing that into the cluster name. Similarly, cluster version, I have taken this from a variable. Subnet IDs, we will be using the subnet IDs that we have created within the VPC file, and some tags. Along with that, the node group, EKS managed node group defaults. Sorry, we will not be using the self-managed node group. We will be using the EKS managed node groups, my bad. And within the EKS managed node groups, I have provided what should be my AMI type, what should be my instance type, and what should be my VPC security group IDs. This is what I have explained in the beginning of the video. When we are using the EKS managed node groups, which will create an auto scaling group, here you can provide what should be the minimum size, what should be the maximum size, and what should be the desired size of your node group. You can change this accordingly. You can keep it 1, whatever you would like to, right? So this is about the EKS cluster file. Then comes the security groups, wherein the security group, the configuration is very basic. I have not complicated it. I've just provided some CIDR block ranges, and I've created the inbound traffic rules and outbound traffic rules. Again, I've not complicated it. I've just kept it very, very basic. This is the important point. You should always look at using variables. Most of the times you will have the necessity to use the variables. So here I've created variables for the Kubernetes version, VPC CIDR, what is the default CIDR block range, and AWS region. But of course, you can also variabilize this Terraform project even more. Some of the CIDR block ranges I have hard coded. You can keep that in the variable format as well. Outputs.tf. This is important just for us to, once the Terraform project is executed, right? You will get the output as Terraform project is successfully executed. But instead of going to the AWS portal and looking at some of the details, such as what is my EKS cluster name that is created, or what is the EKS cluster URL, or what is the kubectl command, or what is the region in which it is created. Let's say you want to get this basic information. You can use the outputs.tf file, and you can use this syntax. So output is a keyword followed by whatever is the thing that you want to print. Let's say I want to print the EKS cluster ID. So I'll simply say module.eks.cluster ID. Similarly, if I want to get the AWS region, which is already stored in the variables, so I'm just using the same thing. Otherwise, you can also retrieve it from any of these resources. So you can say module.eks. Wherever the region is in the EKS JSON format. Let's say module.eks.region, something like that, using which you can print any kind of output that you want to see once the Terraform project execution is successful. So this is all that we have in the Terraform files, and all these Terraform files, like I've told you, are shared in the GitHub repository. You can reference them. It will take a lot of time to write these Terraform files. Even for me to write it by taking help from the AWS documentation and other sources, it has taken a lot of time. So it's not that anyone can write it for the first time. You need experience, you need expertise. By looking at these files, you can follow the same thing. You can either execute it, but what I will recommend is firstly execute it as I've shown in the video. Second time, try to take help of this GitHub repository, take help of the AWS documentation, and try to write these files by yourself. Now let's get to the terminal and try to see how to execute this project. So git remote -v, just to show you I'm on the same project. I am Veeramalla, Terraform EKS.git. So we are all on the same project. And if I do git status, there is nothing that I have here. So it's the same files that you're seeing here. Start with Terraform init and do not miss the output here. Try to see each and every line what is happening. So it said initializing the backend. We don't have the backend. We are using the local backend itself. We are not using S3 bucket or something. So it initialized. Then initializing modules. What is this modules here? So this modules is the Terraform EKS module that we have used. Then within that, we are using the EKS managed node group. It got all that thing. Then the next thing is it is using the VPC module that we have used, and it put all of this information inside the .terraform folder. So when you are using the inbuilt modules, so Terraform, once you run Terraform init command, it will download all this information and it will create ls minus ltr. You will not see it, but when you do it ls minus ltra, you will see this .terraform folder. Within the .terraform folder, you will see the modules. And if you go to modules, here you will find EKS and VPC, right? Why did you find the EKS and VPC? Because we have downloaded it and we have used it in the modules section in the Terraform files, right? We have used them as modules in the Terraform files. That's why Terraform has downloaded it when we executed the Terraform init. Along with that, it also gets the providers that you are using here. So if you go to the providers folder, we are using the AWS provider, right? So registry.terraform.io, cd HashiCorp. Here we are using the AWS provider. We are using the null provider. We are in all of these files, we are using all these providers. If you just dive into the Terraform files, you will see that I'm using AWS provider, Kubernetes provider. This is there from one of my previous scripts. Initially, when I wrote this Terraform files, what I've done is I've used Kubernetes provider just to show you once the Kubernetes cluster is created, that is EKS cluster is created, how to use Terraform to also create resources such as namespaces, all those things from the Terraform itself. For that, I use the Kubernetes provider. But later I thought the video is getting more complicated. There are so many things that will be in the video. So I just removed that part. Then I'm using the null provider. Basically, null is used. Let's say you want to run any remote execution, right? You don't want to use any Terraform thing, but when you run the Terraform apply, probably as part of the same Terraform execution itself, you might want to run a shell script, or you might want to run a remote execution. In this case, we are using remote execution where I'm using a null provider. Cloud init, again, it is not there in this particular Terraform files, but previously I used cloud init and I did not delete them from the Terraform init. So you might think that, but Abhishek, where you have all of those things? So if you just go back, like when I run Terraform init, they should all go away, right? But Abhishek, why do I still see them? If you go to this files called version.tf, in future, I might upgrade this repository. So I just have the things here. I have the cloud init, I have the null, I have Kubernetes. Although I can just remove these things which are not required at the current stage of this Terraform files, but I just kept them so that I can upgrade this entire thing. You can also get rid of Kubernetes easily. You can get rid of cloud init. You don't need null also, I believe. I've removed the null related changes also. Perfect. So that is where when you run Terraform init, it downloaded all those providers. If we did not have them in versions.tf, they wouldn't have been downloaded. Cool. So Now we have Terraform init done. Let's try to run Terraform plan and see what is it creating. It should create all of these things, right? The VPC configuration, whatever we saw here. On the eraser screen, so we have VPC, EKS managed node pools, which will create the worker nodes using the auto scaling. We have the security groups. All these things should be created. So it says 55 resources to add, 0 to change and 0 to destroy. If you just try to go through this plan, you will see the same things. Spend enough time here, try to understand each and everything that is happening. If I try to explain each and every line, or if I try to write, it will take easily 4 to 5 hours for me to just explain these things. That's why I'm not going into details. You can just read through the plan output. Now, finally, you can run Terraform apply. You can also pass --, auto approve, so that I don't have to enter yes. If you're confident with plan, you can do it. Otherwise, you can just wait for it, right? So it is creating 55 resources and it will take a lot of time here. And each and every line that is getting created, please try to focus. I have done this multiple times, so I will find a lot of things familiar. But when you read through the lines, you will understand, like when the VPC is getting created, you can try to understand what is getting created in the VPC and what is the order of the resources that are getting created. You will find out that a route table is being created, internet gateway. Of course, it doesn't mean the resources are getting created in the same order. But if you just try to see it, you will at least come to know what are the resources that are getting created. VPC, within the VPC internet gateway, default route table, security group. It is creating all of these resources and it will take maybe up to 10 minutes. It depends on latency, on the region that you are trying to use. So we will wait for 10 minutes while these things are getting created. Okay, so after almost 12 to 13 minutes, we have this entire thing created. And I did not have to modify anything. So just the GitHub files I've downloaded and I've executed. So I have my cluster created, the security groups, and this is the information. If you see the output section, which you are talking about, right? So whatever you have in the outputs file gets printed here. If you want to add more information to what you see here, you can add more to the outputs field, right? So this is the information. And now if we verify, if I go to the EKS thing, and within the US West region, I should see a cluster. So this is the new cluster, Abhi EKS followed by 1, 2, 3, 4, 5, 6, 7, 8 random alphabets or a random string with 8 characters. That is because we have asked, if you go to the vpc.tf file. So here we have created a random resource and we have attached that to the cluster name, right? So this is locals, and within the locals, we have created a cluster name. And here we are appending the random string. This is random string dot suffix dot result, which is output of a 8-digit random string that is appended to this cluster name. And within this cluster, again, if you try to look at the computes, you will not be able to see by default clusters, the nodes and any resources. I will tell you why we need to grant permissions, but you can verify that there is a node group. This is the node group, the EKS managed node group. And if you go to the node group, you will see the same configuration, a auto scaling group with auto scaling group that is created using this launch template. And here, if you go to the launch template configuration, you will see that there are 2 nodes as the desired state and 6 nodes as the maximum. Now let's try to grant permissions because I want to see the resources of this Kubernetes cluster, right? I want to access the Kubernetes cluster. What you need to do is go to this access tab, and within the access tab, create access entry. Again, you can do it using Terraform as well, but I did not want to complicate it further. So create access entry. Just provide what is your IAM role. I'm using root, right? So we need to just find it out. IAM principal ARN or the IAM role that we are using. So let's just let me try to look at it. Standard is fine. We don't have to update this. The IAM principal ARN cannot be changed. Okay, perfect. That is looking good. But your current IAM principal does not have access to Kubernetes object. Yes, create access entry. Yeah, this is the one. So I have to pick the root because I'm using the root user. So this should be the one. Standard is fine. You don't have to change. If you don't create username, also it is fine. If you want to use it, by default, it will create a username for you. Click on the next, select what kind of permissions do you want on this EKS cluster. Let's say I want EKS cluster admin policy, add policy, and click on the next button. Then click on the create. And now, after a couple of seconds, if you refresh, go back to the cluster. And now if you look at the compute tab, you should see the nodes. So this is the node group with the desired state 2. Previously, I was not able to see because I did not have permissions to view the resources on this cluster. Although I'm using a root user, still you will have to go to this access tab and you need to grant or create access entry, right? So this is how we have secured it by default. Nobody will have access to this. Only when you come to this create access entry and grant permissions, only they will have access to the EKS cluster. Now you can go to resources tab, take a look at the deployments that are available in all the namespaces on this cluster. There is only core DNS. You can look at any horizontal pod autoscalers or any resources on the cluster. You can also configure it through the CLI. For that, you should execute the command update kubeconfig AWS EKS update kubeconfig. This is the command followed by name of your cluster followed by the region. So the name of my cluster, this will change every time. This is the last time when I was doing. So I had to do a demo before showing it to you people, right? So just copy this and now you have the kubectl also configured. So this is how we create the EKS cluster and we configure it, we grant the permissions and we access EKS from the AWS portal. You can verify the VPC configuration, security group configuration, everything, but finally don't forget to run Terraform destroy because we have created a lot of resources. We have created node pools. We have created instance with not free trial access, right? So you will be charged as soon as you create this. Just try to get a feel out of it and finally run Terraform destroy so that you will not be charged. Thank you so much for watching this video. I hope you found it informative. See you all in the next one. Take care, everyone. Bye-bye.